Introduction to GPGPU Programming. First, let's see what is a GPU and what does a GPU do. Graphic processing units is one of the most important types of computing technology for both personal and business computing. They are designed for parallel processing purposes. And uh, these GPUs are used widely in a range of applications, including graphics and video rendering. Although they are best known for their capabilities in gaming, GPUs are becoming more popular for the use of creative production and also in artificial intelligence. If we talk about more about GPUs, they are originally designed to accelerate the rendering of 3D graphics, but with time, they have become more flexible and programmable by enhancing their capabilities. This allowed graphic programmers to create more interesting visual effects and realistic scenes with advanced light and shadowing techniques. So, other developers also began to tap the power of these GPUs to dramatically accelerate the additional workload of them to perform them in high performance and with high performing compute. So, now let's see what is the difference between a CPU and a GPU. The main difference between a CPU and a GPU is the speed. The speed of a CPU is less compared to a speed of a GPU because the speed of a GPU is fast when it compared with the speed of a GPU. And also, when talking about the memory consumption, CPU consumes more memory than a GPU. And a GPU, when compared with the CPU, it only consumes a less memory when we compare it with the CPU. And the other thing is that CPUs are suitable for serial instruction processing, but GPUs, they are not suitable for serial instruction processing. They are suitable for parallel instruction processing, but CPUs are not suitable for parallel instruction processing. They are only suitable for serial instruction processing. So the other difference is that mainly CPUs and also GPUs, they both has ALUs, that means arithmetic logical units. But the number of ALUs has in a CPU is very less compared to the number of ALUs which has in a GPU. So even in this figure we can see when we look at the CPU image, it has only 4 ALU units. But when we look at into the GPU image, the number of ALU units are very high, and I think we can see there are thousands of ALU units includes in a GPU. So we can even say these ALU units as cores because the execution now happens inside this ALU unit. So we can say it as cores. So the number of cores in a GPU is very high compared to the number of cores in a CPU. So when the number of cores is high, we know that inside the cores there are several threads. So here in a CPU there are only 4 cores. That means the number of threads if we take one core has 4 threads, then the maximum number of threads which can process inside the CPU is 16. But when we take the GPU, and if we say that inside one core there are 4 threads, then the number of threads inside this GPU will be thousands of threads. So the speed is very high compared to this CPU in parallel processing. So next we'll see what is GPGPU. That means GPGPU means to the general purpose graphic processing units. We'll see what are GPGPUs and what are they used for. When we go back to 2 decades ago, GPUs were primarily used to accelerate real-time 3D graphics, but in such as games. But when the 21st century began, computer scientists realized that GPUs had the potential to solve most of the world's difficult computing problems. So, this realization gave rise to the general purpose GPU era. So, as a result, now graphic technology is applied more increasingly in a variety of large set of problems. Today, GPUs are more programmable than before. And also, when we talk about the flexibility to accelerate a broad range of applications, these GPUs they perform well by going beyond traditional graphics rendering. So here this is some of the uses of GPGPUs, but this is not the only uses, but GPGPUs are used for a large number of users. Some of them are here. I have include for fields of computational chemistry, for sparse matrix solvers, for physics models, for sorting and searching, like such things. Next, we'll see the important part of this GPGPU parallel programming is CUDA. We need to know what is this CUDA and what is it used for. So let's talk about CUDA. But before talking about CUDA, we need to talk about NVIDIA. NVIDIA's graphic processing units they has a very powerful and highly and they are very highly parallel. Therefore, those GPUs has hundreds of processor cores, and each core consists of many threads. So there are thousands of threads running concurrently on these cores. And when talking about CUDA is a device architecture which is used in parallel programming, and it was released by NVIDIA in 2007. And the most important thing here is that it supports only NVIDIA's GPUs. So if a programmer wants to work with CUDA, then that programmer should have a computer which supports NVIDIA graphic cards, and then if that person's computer supports NVIDIA graphic cards, then they can install the late CUDA version according to their graphic card, and they can perform parallel computation using those computers. When we talk about more about CUDA, the term CUDA refers to two things. First, it refers to the massively parallel architecture of modern GPUs with hundreds of cores, and second, it refers to the CUDA parallel programming model which is used to program these GPUs. So we need some way that we can program all these cores efficiently and easily. So as a result, CUDA gives us a way where we can efficiently process thousands of elements for a particular task in parallel. For example, if I say, when we simply write a program for one data element, then it gets automatically distributed across thousands of the cores and thousands of threads which are found in these GPUs. So next we'll see how does a GPU program work. When talking about a GPU program, the main thing is that a GPU cannot handle the program itself on its own. It needs the support of the CPU. So the CPU and GPU they work hand in hand in this process. When we code a program, the CPU is the one who takes the input data, and then it transfers those data into the GPU. But the GPU they can't directly access the input data from the program, it needs the support of the CPU to do this task. So after that, the CPU calls the GPU program, also known called as setting of kernels, where it set the kernels. So after that, when finishing the execution, again CPU takes back the result output from the GPU and it copies it into the CPU's memory. So that is how a GPU program works. So we will go deep into a GPU program. In the next video, I will explain how to code a program by using CUDA and parallel programming in the next video. We'll see how by using this CUDA specialties, and we'll see how by using these GPUs how we can make our code run faster than running that same code in the CPU.